So first we will talk about CI engine. So you can see here there are six figures of this piston and cylinder arrangement. So you can see here this is actually cylinder. So this is cylinder, this one, and this is piston. This is connecting rod here to here, and this connecting rod is connected with the crank. This is crank pin and this is crankshaft, and this is inner dead center and this is outer dead center, or you can say this is TDC or this is BDC. So actually in the case of vertical engine it will be TDC, top dead center, and this will be bottom dead center. If this engine is horizontally aligned, then this will be IDC and this will be BDC. So here you can see actually this piston is reciprocating this cylinder. So this is going vertically upward and vertically downward in this case of vertical IC engine. So here you can see this is the maximum limit of this piston to move in the upward direction, and this is the lowest means position of this piston in the downward direction. So this will be bottom of this piston and this will be top of this piston, means this will be bottom dead center. So beyond this limit this piston cannot go in the downward direction, and beyond this limit this piston cannot go in the upward direction. So this is top dead center and this is bottom dead center. So this is actually dead position of this piston at this position and at this position. So this is actually connecting rod, this is crank, this is crankshaft, this is means crank pin. So this is inlet valve, this is outlet valve, and you can see this is the clearance volume. You can see here VC, and this piston is moving TDC to BDC. So this is moving in this distance, and this distance is called stroke length. So this length is stroke length, and during this movement of this piston in this TDC to BDC condition, so this volume covered by this piston will be swept volume VS. So here this is air injection system, means air, sorry, fuel injector in case of CI engine, and in case of SI engine it will be spark plug here. So here you can see this piston is at the top dead center, and now it is moving vertically downward. So in this situation this exhaust valve will be closed, inlet will be open, then this piston will suck air in this cylinder during this movement of this piston. So this piston is reciprocating TDC to BDC, and some volume of air is entering in this cylinder. So this process is called suction stroke. So here this piston is moving from TDC to BDC. So finally at the end of this suction stroke this piston will be at this position at the bottom dead center. So you can see this piston here. So this is the second position. So this piston is at the BDC position because this is moved from TDC to BDC. So this is the bottom dead center. So you can see the air is entered in this cylinder. Now this piston is moving vertically upward. In this condition inlet and outlet both valves are closed. So this piston will move here to here TDC. So this will be the compression stroke. So at the end of this compression stroke this piston will be at TDC condition. You can see in this figure. So piston is at TDC condition at the top dead center. So you think one more statement. So this is actually piston and this is moving TDC to BDC. So actually this piston is moving means in a vertical direction, either in upward direction or in downward direction, means it is reciprocating. So this piston is reciprocating top to bottom, bottom to top, in all these figure you can see. So this piston is in reciprocating motion, and this reciprocating motion is converted into the rotary motion by the help of this connecting rod, crank and crankshaft. So this device is converting this reciprocating motion into rotary motion. So now we were talking about the compression stroke. So this compression stroke is completed. In this figure you can see. So this piston was at the BDC when the compression was started, but at the end of compression this piston will be on the top dead center. So you can see this piston at TDC in this third figure. So at the end of the compression stroke, this piston will be at this position at TDC. So now the fuel is injected by the help of this injector. So you can see when we were injecting the fuel, this piston is moving this location to this location because this fuel is occupying some volume. So when we injected the diesel in this cylinder, this piston was shifted here to here. So this volume is occupied by the diesel in this cylinder. Now this piston will move further vertically downward direction because we have injected the diesel in this cylinder, and during the compression stroke this air was compressed, and due to higher pressure the temperature of air was very high, so it was up to the ignition temperature. So when we injected the diesel in this combustor chamber, it was burnt automatically due to high temperature. So due to the combustion of fuel, this uh, piston will be moved vertically downward due to higher pressure. So this will reach to BDC condition, means bottom dead center. You can see in this next figure. So actually this movement of the piston here to here was the power stroke or expansion stroke. So actually at the end of this stroke, this piston will be here, and this volume will be swept volume here. So this will be expansion stroke or power stroke. Again this piston will move here to here, you can see in this figure. So this piston is at the BDC condition at the end of this power stroke. Again this piston will move BDC to TDC, and in this condition the exhaust valve will be open and inlet will be closed. So the heat will be rejected via this outlet valve, and this piston will be at the BDC during this process or stroke. Further, the burnt gases will be thrown out from this cylinder into the surroundings by the movement of this piston. So this piston will move vertically upward, means BDC to TDC, and the burnt gases will be thrown out from this outlet into the surroundings. So this was the exhaust stroke. So actually this was suction stroke, this was compression stroke, this was expansion stroke, this was power stroke, this is heat rejection process, and this is exhaust process. So there were 6 conditions of this piston: first condition, second condition, third condition, fourth, fifth and sixth. So now we will talk about pressure and volume diagram. So from the first figure we can see this piston is moving TDC to BDC, and inlet valve is open, outlet is closed. So during this stroke the volume of this cylinder will be increased. You can see here volume is increasing and pressure will be decreased. So you can see at this point pressure is lower than the P atmospheric, means atmospheric pressure. So here actually this inlet valve is open, so the pressure inside this chamber will be atmospheric. When this piston will move TDC to VDC, vacuum will be created due to this suction process. So at this point this will be pressure lower than the atmospheric pressure. So this piston will move TDC to BDC. So this is actually TDC, and this piston is at this position. When at this position, so this will be BDC, bottom dead center. So at the top dead center pressure will be atmospheric, and at the bottom dead center pressure will be atmospheric, but in between it will be lower than the atmospheric pressure. So this is actually suction stroke. So we have drawn this suction stroke in PV diagram. Now this piston will move BDC to TDC, and both the valves are closed. So you can see when this piston is moving BDC to TDC, so this volume is decreasing. You can see here volume is decreasing 1 to 2, and due to decrease of this volume the pressure will be increased. So you can see here at point 1 pressure is P1, at point 2 pressure is P2, means pressure is increasing. So due to movement of this piston, volume is decreasing, pressure is increasing because both valves are closed. So this is compression stroke. Now we will talk about heat addition stroke or process. So you can see this piston was at the TDC condition, okay, and air is compressed fully at higher pressure. Due to higher pressure the temperature was very high, means it is very close to the ignition temperature when we injected the diesel in this combustion chamber. So the compressed air was mixed with the diesel, and the temperature was very high. That's why ignition of fuel was started. So due to ignition of fuel, expansion will be started. But before expansion stroke, we would like to talk about the fuel addition process, means fuel injection process. So here you can see the piston was at the TDC position, you can see in dotted line, and we added the fuel. So this is actually amount of fuel. So due to addition of fuel, some volume of this cylinder will be occupied by the diesel. So by the injection of this diesel, this piston is moved from this location to this location. So this volume is covered by the diesel. So you can see this piston is moving here to here due to injection of this diesel, and diesel is increasing the volume. This volume, you can see volume is increasing 2 to 3, but this volume is increasing at constant pressure. So this heat addition process is at constant pressure. Now this piston will move due to combustion of this fuel. Due to combustion of fuel, the piston will move vertically downward because of higher pressure. So in this third figure you can see this expansion process is taking place, means here to here. So you can see this is adiabatic expansion, means 3 to 4, entropy will be constant, and this adiabatic expansion is also called power stroke. So this is actually power stroke. So during this power stroke both the valves are closed. Now this piston will be at BDC at the end of this expansion or power stroke, you can see in this third figure. So now at the end of this power stroke, the outlet valve will be opened. So due to opening of this valve, at the BDC condition of this piston, heat rejection process will be completed because this piston is not moving at this time, and the heat is rejected. So this will be heat rejection at constant volume. Because piston is not moving means volume is not changing. Further, the burnt gases will be thrown out into the surroundings via the outlet valve, and this piston will move BDC to TDC. So this volume is decreased. So due to decrease of volume, the pressure at the midpoint will be higher than the surroundings. So in this duration, the outlet valve will be opened, and burnt gases will be thrown out into the surroundings by this outlet valve. So in this figure you can see there are separate processes: suction stroke, compression stroke, heat addition, expansion stroke or power stroke, heat rejection, and exhaust. Now we will assemble these six processes. So in this figure you can see this is a PV diagram for these all processes. So this will form a cycle. So this cycle is called diesel cycle. Diesel cycle. Okay, so first is the suction process. So you can see this is atmospheric pressure, and 0 to 1 is suction process. You can see pressure is lower than the atmospheric pressure, and 1 to 2 is adiabatic compression process. 1 to 2, this is adiabatic compression process, and 2 to 3 is heat addition process, and 3 to 4 is expansion process, and 4 to 1 is heat rejection at constant volume, and then this is exhaust, means 1 to 0. Okay, so this is actually diesel cycle. Now in this figure you can see this is a vertical alignment of this diesel engine, and this is horizontal alignment of this diesel engine. So in case of vertical alignment, this will be top dead center, and this will be bottom dead center, and in horizontal it will be inner dead center, and this will be outer dead center. So this is the main difference between vertical and horizontal alignment of this IC engine. So this may be petrol engine or diesel engine. It depends on the fuel. So now you can see in this picture. So this is a petrol engine, which is called SI engine, spark ignition engine. Okay, and this is diesel engine. It is called compression ignition engine, CI engine. So actually in case of petrol engine, carburetor is required. This is carburetor. So carburetor is required to mix the air and fuel in a proper ratio, and this is spark plug. Sorry, this is a spark plug to provide the sparking, and the carburetor is another device which mix the fuel and the air in proper ratio. So in this case there is no need of carburetor and spark plug. So in this case of diesel engine, there is no need of carburetor and spark plug, but in case of petrol engine, spark plug is required for the sparking of the air fuel mixture, and carburetor is required to mix the air and fuel. So this will provide proper mixing of air fuel in particular ratio. This will be around 1 to, means 14, 15 something. So here you can see this is SI engine and this is CI engine. So I have already discussed about the CI engine, but in case of SI engine, means petrol engine. So in case of petrol engine, we inject or supply air and fuel mixture into this combustion chamber during the suction process, and during this process this piston will be at IDC condition. Okay, so suction will be completed. Then this air fuel mixture is compressed during the compression stroke, and at the compression stroke this air fuel mixture will be in this control volume. Okay, so we will provide sparking from the spark plug, so the combustion of fuel will be started. So this process is called heat addition process, and during this process this piston will be at IDC in the starting and at the end of this heat addition process. So you can see this complete process, means heat addition process 1 to 2, 2 to 3, 3 to 4. So this heat addition process 2 to 3 is completing at the constant volume because this piston is not moving in this condition. So this whole process 2 to 3 is completed at this constant volume. So this is actually volume. So volume is constant, but pressure is increasing. So the stationary or fixed position of this piston, heat addition is taking place because compressed air fuel mixture is uh, ignited by the sparking. So again, this piston will move here to here, IDC to ODC. So expansion of this fuel combustion will be take place during 3 to 4, and this process is called adiabatic expansion stroke or power stroke. Again, this piston will be at the ODC condition. In case of vertical engines, this will be BDC. So at this fixed position, outlet valve will be open and heat will be rejected by the outlet valve. So this will be heat rejection at constant volume. Again, this piston will move ODC to BDC. Then compression will be started. So this will be repeated further. So here you can see the heat addition is taking place in case of petrol engine at fixed position of this piston at IDC or TDC, means the volume is not changing but pressure will be increased, and it is due to the combustion of air and fuel mixture because air and fuel both are injected initially. But in second case, in CI engine, only air is sucked and this air is compressed up to a ignition temperature. So it is compressed due to higher pressure. The temperature was increased up to the ignition temperature. Then the fuel was injected. So due to injection of fuel, this fuel will take some volume. Suppose this volume is shifting this piston here to here. Okay, so due to the addition of fuel, this piston move this position to this position. So this is actually volume occupied by the fuel, means diesel. So this volume is increased 1 to 2. But during this shifting of this piston, the pressure is constant, means due to fuel injection, volume is increasing 1 to 2, but pressure will be constant. So this was the basic difference between heat addition process in CI engine and heat addition process in SI engine, and remaining part will be same. Adiabatic expansion, this is adiabatic expansion, constant, sorry, heat rejection at constant volume, heat rejection at constant volume, compression at constant entropy, means adiabatic compression. This is also adiabatic compression. So this was the basic difference between SI and CI engine, and this is also TS diagram for these two engines. So you can see so here you can see this heat addition process is taking place at constant uh, volume. So this is heat addition process, and rejection of heat is 4 to 1 at constant volume. This is 4 to 1 at constant volume. So this is heat addition, this is heat rejection. Okay, and this is 3 to 4 adiabatic expansion. So this is adiabatic expansion at constant entropy, and this is adiabatic compression at constant entropy. Similarly, here you can see this process is equal to this process, this is similar to this process similar to this process, but basic difference is of heat addition process in both the cases. So here heat addition is taking place at constant volume, and here heat addition is taking place at constant pressure. So thanks for watching this video. Wish you all the best.